Hey guys, today we're going to take a look at solving equations with parentheses. So first I want you to stop the video and copy the notes that I've set here. These are the steps to solving multi-step equations. So now that you've copied these steps down, let's talk through them before we practice them. So anytime you see a multi-step equation, such as the one that I'm writing here, x plus 3 times x plus 4 equals 20. You talk yourself through these steps every single time. So first you look for the distributive property. Next you look and combine like terms on the left side and on the right side by adding or subtracting. And last you isolate the variable or letter using inverse operations. So first you add or subtract, then you multiply or divide. So let's practice these steps. So number 1, x plus 3 times x plus 4 equals 20. I want you to listen to how I talk through these steps every time. First, do we see the distributive property? When you see the distributive property, or you know you have the distributive property when you see this right here, it's the parentheses that's a dead giveaway. So usually I like to bring everything down that's not a part of the distributive property. And now I do the distributive property. So 3 times 1x is positive 3x. 3 times 4 is positive 12. And now I have a brand new problem. X plus 3x plus 12 equals 20. I don't see any more parentheses, so I do step 2 of my process. Combine like terms on each side. Well, first I'm going to look on the left side. Do I have like terms on the left side? Yes, I do. I have x plus 3x. So again, I'm going to bring down everything that's not a part of the like terms. And now I'm going to combine like terms. 1x plus 3x is 4x. So my new problem is 4x plus 12 equals 20. And last but not least, we use inverse operations to isolate the variable. This is what we're used to with 1 and 2 step equations. So I find my variable. And first I add or subtract whichever is the opposite. The opposite of plus 12 is minus 12. So I'm left with 4x, 12 minus 12 cancels, equals, and 20 minus 12 is 8. And then I notice I still have a times 4 hanging on to my variable or letter. So I do the opposite. The opposite of times 4 is to divide both sides by 4. So x equals positive 8 divided by positive 4 is positive 2. So 2 is the solution to this equation. Or when I plug 2 back into the equation, it makes it true. So let's try another one. Number 2, 6 times x minus 1 plus 8 equals 32. I always like to divide my equal sign or my equation at the equal sign. So step 1, and I always go back to these steps that we've written down. Step 1, do I have the distributive property? Well, when I look at this, I see parentheses, so yes, I do have the distributive property. So I bring everything else down before I start doing the distributive property. 6 times 1x is 6x. 6 times negative 1, signs are different, so it's a negative. 6 times 1 is 6. So my brand new problem is 6x minus 6 plus 8 equals 32. Step 2, do I have like terms? Well, when I take a look at my equation, on the left-hand side, I notice a negative 6 and a positive 8 are both constants or plain old numbers. So yes, I have like terms. So I bring everything else down before I combine those. What is negative 6 plus 8? Well, it's positive 2. Different signs, subtract, keep the sign of the bigger number. And now I'm left with just a plain old 2-step equation like we're used to. So I'm going to isolate using inverse operations, add or subtract first. So the opposite of plus 2 is to subtract 2 from both sides. So I'm left with 6x equals 2 minus 2 cancels, and 32 minus 2 is 30. I notice I still have something hanging on to my letter or my variable. So the opposite of times 6 is to divide both sides by 6. So x equals 30 divided by 6 is 5. So 5 makes this equation true, or it's the solution to this equation. Number 3, I have 5 plus 4 times x plus 9 equals negative 3. So split it at the equal sign. First, I have the distributive property, so that's what I'm going to do first. So I bring down my 5 equals negative 3. And now let's distribute the 4. 4 times 1x is positive 4x. 4 times 9 is positive 36. I'm just using my integer rules to multiply. Same signs positive, different signs negative. Step 2, do I see like terms? The right side, no, but the left side, I see 5 plus 36. Those are alike because they're constants. So I'm going to go ahead and bring down my 4x equals negative 3. And 5 plus 36 is positive 41. At this point, if you want to use your calculator for these integers for adding, subtracting, that's fine with me. And now I'm just going to, step 3, isolate my variable, first by adding or subtracting, then multiplying or dividing. So the opposite of plus 41 is minus 41. So I'm left with 4x, 41 minus 41 cancels. Same signs, I'm going to add these numbers and keep the sign so I get negative 44. And my final step, the opposite of times 4 is to divide both sides by 4. So x equals negative 11, because negative 44 divided by positive 4 is negative 11. So negative 11 is my solution. Let's try a couple more just to make sure you're comfortable. So take a look at number 4. 5 times x minus 2 minus 8x equals negative 34. So draw your line at the equal sign. Do I see the distributive property? Yes, I do, right here. So I'm going to bring everything else down just so I won't forget it. So 5 times 1x is 5x. 5 times negative 2 is negative 10. So now I'll look at my new equation. Step 2, do I have like terms? Yes, I do. On the left-hand side, I see 5x minus 8x. So I'm going to bring everything else down so I don't forget it. And now I'm going to do 5x minus 8x, which is negative 3x. Now I notice I have a two-step equation, so I isolate the variable first by adding or subtracting. I have a minus 10, so I'm going to add 10 to both sides. Do the opposite. Negative 3x equals, these signs are different, so I'll subtract and keep the sign of the bigger number, which is negative. And then last but not least, I do notice I still have a times negative 3 on my, hanging onto my letter. So I'm going to divide both sides by negative 3. So x equals positive 8. Guys, take a look at this one. So I have 2 equals 11 plus 3 times x plus 3. What do you notice about this one? Actually, I don't even want to split that yet. That looks like crazy different, but it's not. All you have to do is flip it. So I'm going to say 11 plus 3 times x plus 3 equals 2. Now I'm going to split it and do it just like normal. So first, do I have the distributive property? Yes, I do. I see it right there. So I'm going to bring everything down that's not a part of that. And 3 times 1x is 3x. 3 times 3 is 9. Next, do I have like terms? Yes, I do. On the left-hand side, I have 11 and 9. So I'm going to bring everything else down just so I won't forget it. And 11 plus 9, add those together to get a positive or plus 20. And now I've just got a two-step equation, so I'm going to do inverse operations. The opposite of plus 20 is to subtract 20 from both sides. So I'm left with 3x equals 20 minus 20, cancels. 2 minus 20, signs are different, so I'll subtract, keep the sign of the bigger number, so negative 18. And then I notice that I still need to get rid of that times 3, so I'm going to divide both sides by 3. So x equals negative 6, because negative 18 divided by positive 3 is negative 6.